Morning, CSEC students. Welcome back to another live class. This morning, we're going to be looking at graphs, how to plot linear and quadratic graphs. We've done this before, but it's always good to have extra practice. This morning, we're going to scratch and talk about the coordinate plane or the Cartesian plane and the difference between the linear and quadratic graph and how to plot. In terms of the linear graph, word there being line, coming from the word line, so that indicates that plot that graph on your coordinate plane, you are going to get line. The line can be oriented vertically, so a straight vertical line, or it can be a straight horizontal line, be an oblique line. It can have an incline. We're going to look at those. For the quadratic, the variable, which is usually an x, but it can be any letter. But usually when we're writing the function on graph, it's y equal something x. Well, with the quadratic, it's going to be x squared. So the highest order of the x variable is at 2, x squared. The simplest quadratic function then would be y equal x squared. We can have y equal negative x squared. We can have y equals 4x squared plus 10x squared plus 6. So they can get more and more complex. The general idea, though, is that the quadratic, you're going to get a curve with a full part of a curve, and that curve is called a parabola. When you're plotting your functions or your equations, in addition to the function, you're given a domain. If you're given a domain, you can choose one, but oftentimes you're given your domain is your set of values, and that value where you're going to start. It will give you an indication of how wide parabola is going to be, whether it's going to be the full parabola or a fraction of it, a section of it. We are also going to be looking at the scale, because you have to use a scale on your axis to plot your graphs. The scale is the distance between the numbers on your axis. So whether you're going to go 1, you can go by 2, go by 5, and you decide. Or sometimes you are told. So sometimes in the exam you are told which scale you must use on which axis. If you are not told, then it's just up to you to look at the numbers and decide what scale am I going to use to ensure that all these numbers can hold on this. So let's go to a Cartesian plane. So it's called a Cartesian plane of René Descartes, who was a French mathematician. We also call it the coordinate plane, and we're going to plot our coordinates, our x values and y values, pretending that these lines are straight. And the arrows that I have on each axis is the x-axis. The horizontal line is your x. The vertical line is your y-axis. Here in the middle, we have the origin, which is 0, 0. So our set of coordinates, the first will tell you your x value. The second number will tell you your y value. We move, and then we move on the y, and then we put the point that we get. So focusing on the x-axis, the horizontal line, to the right of the origin, these are positive values, positive x values, and they go to positive infinity. To the left of the origin, we have our negative x values, also go to negative infinity. Above the origin, so on the vertical line, we have positive y values, which go to positive infinity. Below the origin, we have our negative y values, which go to negative infinity. If you are given a scale, follow that scale. If not, you can decide which scale to use. Let's say on the x-axis, if we're going up by 1, sometimes your x values are much smaller than the y values, usually, not always. So let's say we're going up by 1, 2, 3, 4, and so on. Have our negative x value, negative 1, negative 2, negative 3, and on your y value, so whatever scale you use for your x-axis, scale should be consistent all the way across the x-axis. Likewise, whatever scale you use for the y-axis, it should be consistent. You can't go up by 2 at the top and then bottom. If you decide that you're going to go up by 5, it should be right along the y-axis. Going up by 5 on our class 5, 10, 15, and below that now we would have negative 5, negative 10, 15, and so on. All right, so yeah, of the scale. So let's plot some. So here we have 3, negative 5. Let's have 0, 4. Let's have negative 1, 6. Let's do 3 more. Let's so 2, 3, negative 10, and 0, negative 11. All right, so we're going to plot these points. So remember, you move on your x-axis first. So the first number tells you move on x-axis, and this number tells you where you move on your y-axis. Make the point. So it's not that you will make a point on the x, make another point on the y. You move in pairs first, and then you point. So for the first one, the first point, it says 3, negative 5. So that means 3 on the x and then negative 5 on the y. So it's a positive 3 on the x. So we're going to move to the right. So we'll go across to 3, yet go down from there to negative 5. So negative 5 stop there, right? So where 3 meets -5, that's here. This is where we put the point. So that's 3, -. So let's say that was point A. So we would put A there, right? Right. Next one, 0, that's B. Let's give them letters. So B, C, D, E, F. So it says 0, 4. X value is 0, not going to move. So we stay at 0. We don't move on the X. And then the value is 4. So we're going to go up to 4. Still on the y-axis because we move on the X. So that will be where it is. 0, 4. C, -1, +6. So we move across on the X, -1. And from there, we go up to 6. So that's C. D says 12. Positive X, positive 12. So from 2 on X, go up to, so this is 10, so I'm estimating 12. Paper, you won't have to estimate because kind of accurately. You can take your reading. For E, 3 on the X, -y. So 3 on the X and then down to -E. And D says 0 on the X, -11 on the Y. So at the origin, that's 0. We don't move on the X, and we go down to -11. So this is F. So that's plotting. This is plotting points. So when you're given let's look at some linear functions now. So let's look at line y equals 3, y equals -6, and y equals, let's say y equals 5. So these are 3 different coordinate planes. This simple line, y equals 3, just means you're just, no, this is unacceptable. I can't ask you to imagine that this one is straight. This is unacceptable. I have to do better than that one. All right. So straight across. All right. That's a little better. For the line y equals 3, all we need to do is find where 3 is on a straight line across from there. That it's a plain and simple line. Y equals 3. Wherever 3 is, you're going to straight across. That's the line y equals 3. And usually we write the function on the line. So we'd put y equals, for y equals -6. So on the y-axis, where -6 is, wherever it is, your line is going to run straight through that point. Straight through that point. That's your line. Y equals -6. It's a plane. Likewise, y equals 5. Just find where 5 is on the y-axis and across. plain and simple. So these are really, really, but you need to know that. For example, when you're doing your linear programming down in the course, you're given a set of equations and you have to plot them on the same graph paper. And one of them might say y is greater than or equal to 5. So you have to know where to draw the line y equals 5 so you can go further with that. So as simple as it is, this is basic that you must know. So let's look at some simple thing, x. So for example, x equals 2, x equals negative 3, x equals 10. It's similar to the line y equals just a constant. The difference though is instead of a vertical line, instead of a horizontal line, we're going to end up with a vertical, because we're going to find where that number is on the x and then draw a straight line through that point. So for the line x equal 2, find where 2 is. So let's say 2 is here on the x-axis. The line would go straight down through that point where x equal negative 3. So negative 3 would be on the left side. So that line would run straight through the point negative equal 10, where 10 is, straight. And y equals a constant term is a straight horizontal line. The line x, a constant term, is a straight vertical line. Not two simple equals negative x. All right, Lejeune is asking where the number. Remember, your graph would be labeled with it. I'm not putting the scale. You would have ruled up the graph with 1, 2, 3, 4, and so on. So you would know where the number is. You would find the number and you draw through that number, right? I'm just sketching the graph. I just put in the number where I'm just estimating where the number could be and drawing the line down. You would have ruled up your scale and everything on your graph paper. So you would know where the number is and through it. That y equals x. This is a common line that you should know. And we're going to look at also y equals negative x. So for the line y equals x, if x, that means whatever y is, x is. Therefore, whatever y is, x is. So if y is 1, x is 1. If y is 2, x is 2, y is 3, and so on. Is again, I'm estimating on my board. You would plot your actual numbers on the graph. So when y is 1, when y is 1, so 1 would match up to 1, it would be there, right? 2 would match 2, so we'd have the line going something like that. 3 would match up to 3, so 3 on the x would match up to 3 on the y. So what happens for the line y equals x? Have that straight line coming through and origin, because the y is x is 0. That's how that line goes. Y equals x. Y equals negative x. So whatever y is, x is negative. X is negative 1, y is 1. So -1 on the x would go to 1 on the y. -2 on the x would go to -2. Same way, x would go to -1 on the y. So what for this line then, it would come this way. So this is the line equals -x. Them go through the origin. Line y equals x is oriented to the right, positive, and the line y equals -x is oriented to the left because it is negative. So now we're going to plot a graph that's a little more complicated. So for example, y equals 2x plus 3. And let's say we were given a domain -3 to 4. So the domain, this DOMAIN, domain tells you where your x value should start and where it should stop. So we're going to start at -3, stop at 4. To draw a straight line, you only need 2 or 3 points to connect and you get a straight line. So we're only going to use our endpoints. And usually we like to put 0 in the middle, happening at the origin. All right. So x values, -3, 0, 4. So -3 stop at 4 and we put 0 in. Now we're going to put our function 2x plus 3. So this is how you're going to set up your table when you're plotting your linear function. Look at the function and see what they want you to do with the x values and just write that in the table. So the first thing they want you to do is to multiply the x values by 2. So and that will go 2 times 3, that's -6. 2 times 0 is 0, is 8. To add 3 to each of those. When we add 3, that's -3. 0 plus 3 is 3, and 8 plus 3 is 11. So these are our pair of values that we're going to plot. So the x value is -3, the y value is also -3. So that's -3, -3. When x is 0, y is 3. So 0, 3. And when x is 11. So 4 to 11. So now we need to plot that. So put in our x-axis, put in our y-axis. Here we have 0. The scale on the x, 1, 2, 3, 4, negative, -3, negative. On the y, our biggest y value 11. So we can go by that will be all right. So 5, 10, 15, because we all, In the negative y's, we have negative 5, negative 10, negative 15. All right, now we just need to plot our points. Negative 3 on the x, negative 3 on the y. So we move across negative 3 on the x and down to negative 3 on the y. 0 on the x, 3 on the y. So this is not moving on the x, and we'll go up 3 on the y. And then 4 on the x, 11 on the y. So 4 on the x-axis up to where 11 would be. So where the 4 and the 11 meet each other. So that's about there. And now we're going to our points. So you would use your ruler. For that, you use your ruler and you connect the ruler to the 3 points and draw a straight line, 3 points. And then you're going to write your equation. Y equals 2x plus 3. And it for your linear graph. For the linear graph, so you're given a function, or we call it an equation, y equals plus 3. We need to give us a straight line because the order of the x term is 1. That's x to the first power. So what we do now is we set up a table with our domain. Our domain says x must be greater than or equal to negative 3 or less than or equal to 4. So that's it. So we start at negative 3 and end at 4. And we plug in 2x plus 3. We line that up on the side of the table. That's going to tell us what we're doing to our x values to get to our y values. All right, so it says multiply the x values by 2, and so that's what we did. We multiplied each of the x values by 2. 2 times negative is negative 6. 2 times 0 is 0. 2 times 4 is 8. And then we read to that. So negative 6 plus 3, which is a negative 3, 0 plus 3, and 8 plus 3, which is 11. And we plotted the x values to the y values, and we get our line. So what we're going to do now is we're going to draw a quadratic graph. Right? Let's plot a quadratic graph. So the quadratic graph will have an x squared. So y is, let's say, squared minus 3x plus 4. And let's say the domain is negative 3. Let's use domain negative 4. This is a quadratic. We see the x squared. We're not going to get a straight line. We're going to get a parabola or a curve. Because we're going to get a curve, we can't just use 3 points. We can't use 3 points will not be enough. We have to get all the points at curve. So the domain says negative 3 to 4. We're going to have to plot all the points from negative 3 to 4. We need a wider scale, a wider table. So set up our table, so straight across have all the points on our domain, not just points. So from -3, -2, -1, 0, 1, 2, 3, 4, all of the points for our table. And then we're going to put in the function. The first thing we do is we square the x. So let's have x squared. Then we're going to multiply the x squared by 2. So we put 2x squared to multiply the x's by -3. So we put -3x. And finally, we add 4. And we'll get our y values. So we have to do that step at a time. One step at a time. So let's square our x's first. When you square a negative number, the answer is positive. So -3 times itself, -3 times -3, you'd get a +9. Negative times -2 would give a +4. 1 times -1 would give a +1. 0 squared is 0. 1 times 2 is 4. 3 is 9. 4. Then we add these x squares by, so 2 times 9, that's 8. 2 4 is 8. 2 1's 2 is 0. 2 9 is 18, and 2 times 18 is 32. Now we go to the x's, the x squared is a negative times x. So we go back to these x's. We're going to multiply them by 3. So -3 times this -3, that's a +9. -2, -3 times -1, -3. -3 times 0, 0. Negative is -3. Times 2 is -6. -3 times 3 is 9. And -3 times 4 is -12. Finally, we're going to add all of that. So we put +4 right across. +4, right? The domain is wide, so it seems a bit tedious. You have to go and put in all of them. Add 4 to all these answers. Now we know where to start adding, because we're about to combine our. How do we know? All we need to do is to go and see the first term in the function. In the term is 2x squared. So that's starting in this row. So this row we're going to start. So we're going down. So from the 18 plus 9 is 27, plus 4 is 31. 8 plus 6, 14, plus 4 is 18. 2, 3 is 5, plus 4 is 9. and 4. 2 minus 3 is -1, plus 4 is 3. 8 minus 6 is 2, 4 is 6. 9 is 9, plus 4 is 13. And 22 minus 12 is 20, plus 4 is 24. So if I look at my coordinates, my set of coordinates, seeing that all my y values are positive. So what that says to me is I can manipulate my graph and I can draw only the positive y-axis. So I can draw my x-axis further down on the page so I can have access to most of my y-axis. So -3 to 31, put in those values. -3 on the x is gonna go to 31. So -2 to 18. -1 will go to 9. 0 to 4. These are our coordinate pairs. 1 to 3. 2 to 6. 3 to 13. And 4 to 24. These are our coordinate pairs. So these are what we're going to plot to get our parabola. And like I said, we only need the positive y-axis, because if you look at your y values, all of them are positive. So we're just going to draw a little part of it just to show, just to indicate that the axis is there. However, we're going to focus on the upper part of the y-axis. So let's go to a new page now and actually plot this quadratic so you can see what the parabola looks like. So we have our y-axis. The x-axis, I don't have to draw it in the middle. You don't have to draw it in the middle, or you can draw it anywhere you want based on the values that you're dealing with. So since all my y values are this positive, I'm going to draw my x-axis down here. Just to show the values there. So I can draw it down here. This is 0, the origin, 0, 0, my x-axis. The scale that the biggest value I have is 31. So I'm going to go up by 5. So that's 5, 10, 15, 20, 25, 30. That should do the trick. On the x, our x values are usually small. The biggest x value here is 4. So let's go up by 4. So we have 1, 2, 3, 4. And -1 -2 -3 and -4. So now we're going to plot our points. All right, so remember, -3 went to 31. So -3 on the up to 31. So 31 is about here. I have to estimate on my board. You won't have to estimate. You will get the actual numbers. -2 to 18. So -2 to 18. -1 to 9. -1 to 9. Zero to 4. 0 to 4. 1 to 3. So 1 on the X up to 3. 2 on the X up to 6. 3 to 13. And 4 to 4. So 4 up to 24. All right, so now we're going to join them. For the quadratic, you don't use a ruler. So you use your free hand to connect the points. Remember, it's a curve, so you don't want a ruler. So you just take your time, use your free hand to make that curve. All right, so something like that. We're going to write our equation. So it was y equals 2x. Let me double check that. Y equals 2x squared minus 3x plus 4. So write that along the curve. Y equals 2x squared minus 3x plus 4. All right, and that is our equation. All right, so we'll be doing a couple more classes on plotting, especially plotting the quadratic, because I know that when you're just starting, it can be difficult. We're going to do more classes on how the linear and quadratic functions.